Hi guys. Good evening guys. Good evening everyone. Audio both are clear. Someone respond. Someone tell me audio and video both are clear, all of you. Right. So had your snacks everyone? Right. Sony, good evening. Right. So here what we'll be discussing? We'll be going for third episode today. So what is the third episode? It is based on the elastic deformations and the volumetric strain, you can say, right? Based on the elastic deformations and the volumetric strain, right? Elastic deformations and the volumetric strain, right? What is the meaning of this elastic deformation? Elastic deformation and enti? Deformation occurs within the elastic limits. And enti, when you are removing the load, right, what will happen? It will regain the original shape and size or not, right? Yes, it will regain the original shape and size, right? So, Borelli, good evening, right? Snacks అయిపోయినాయి అందరికి. Everyone snacks over? Tea, coffee, snacks. Right, elastic deformation and these volumetric strains we are going for. So, yeah, Gauss-Peer, good evening. ర్యాంకర్స్పిర్ యాప్ ఎవరైనా డౌన్లోడ్ చేసుకొని వాళ్ళు ఉంటే డౌన్లోడ్ చేసుకోండి ఇమీడియట్గా. ఎవ్రీవన్ డౌన్లోడెడ్ ద ర్యాంకర్స్పిర్ యాప్? డౌన్లోడ్ ఇట్ నౌ. సో నౌ వాట్ విల్ బి గోయింగ్ ఫర్ ఇస్ యాక్సియల్ డిఫార్మేషన్స్ అండ్ వాల్యూమెట్రిక్ స్ట్రెయిన్స్ కదా ఇవాళ. రైట్, శృతి, గుడ్ ఈవినింగ్. సో యాక్సియల్ డిఫార్మేషన్ ఆఫ్ ఏ ప్రిజ్మాటిక్ బార్, రైట్? Axial deformation of a prismatic bar, right? So నిన్న ఎక్కడి వరకు చూసాం మనము? Up to which one we had done yesterday? These elastic constants and the relations we have seen yesterday. Now axial deformations. So this is before loading applied and this is your after loading applied, right? What happens, tell me? This is L plus delta kada. L plus delta. L becomes which one? L plus delta, right? What is a delta? You can say this is not one. So this is your delta, right? This is a increase in the dimension, that is your delta due to this tensile load applied. So how can you get that formula for this axial deformation? Change in the length of a prismatic bar is given by PL by this AE. So P is the axial load applied and A is the cross section area, L is the original length, delta is the change in the length, E is the Young's modulus. Suppose if you are applying the tension, what will happen, tell me? The deformation will be positive, it will cause increase in the length. Suppose if you are applying compression, right, what it will be causing? Pushing, negative deformation and decrease in the length, right? Suppose if you consider this compression. So whenever this compressive load is applied, if you are applying a compressive load P like that, original length is L, and what happens to that? After compressive load is applied, right, how it will become, right? What are the changes will occur, tell me? So it will occur like this. Decrease in the length will occur. This much decrease in the length will be there, right? So this is your delta. And what is this remaining length? Yeah, Srinu, hi, good evening. What is this length, you can say? This is your L minus delta, right? L minus delta under the action of which one? This compressive load, right? Like that. So is that clear, everyone? Increase in the length as well as this decrease in the length, right? For tension force, increase in the length. For compressive force, decrease in the length, right? Now, stepped prismatic bars with axial load at one end only. So ikkada emundi load? Load is acting only at the one end, right? One extreme end దగ్గర load act అవుతుంది. So first దీని cross section area A1, second element cross section area A2, third element cross section area A3. Lengths are L1, L2 and L3 you are having. Lengths of this each segment. E is the Young's modulus. So what will happen? So when you are applying the load at the end, these bars are in which condition, tell me? These bars are like in series condition. When these bars are like in series condition, load is applied only at the one end. ఏమవుతుంది? Load only one end దగ్గర apply చేసినప్పుడు same load will be transferred, right? When you are taking that A3 here, what will happen? This is your A3 member. So right side, what is that? P is there. For balancing this, left side also em undali manaki, left side also P undali. Now, when you are considering that A2 portion, what is the force available? So at this point, right? Let us say this is your A point, B point, C point, and this is D point. So now if you are considering this is CD, so CD member is in equilibrium. Now you consider this is C point is in equilibrium. This is C, this is B. So C point దగ్గర ఏమొస్తుంది? ఇటు లెఫ్ట్ సైడ్ ఉంది కాబట్టి ఇటు ఏమొస్తుంది? రైట్ సైడ్ P వస్తుంది. సో బీసీ మెంబర్ బ్యాలెన్స్ అవ్వాలి అంటే, బీసీ మెంబర్ లోడ్ బ్యాలెన్సింగ్ అవ్వాలంటే ఇది రైట్ సైడ్ P ఉంది కాబట్టి లెఫ్ట్ సైడ్ కూడా ఏమొస్తుంది మనకి? P వస్తుంది, రైట్? సో ఏబి మెంబర్, ఫర్ ఏబి మెంబర్ వాట్ ఈస్ దట్ యూ విల్ బి హ్యావింగ్? ఏబి మెంబర్. So at B will be having P left side. So to balance that, P must be right side here. So for the member AB, point balancing is done. Now member balancing. How to take? Right side P is there. So on the member, entire member, left side P will be there with this A1. So what you can have now, tell me? What you can have now, tell me? Every part is subjected to this same load P only, no? Yes or no? So since the load is applied only at the one free end, there are no other loads in between. P1 equal to P2 equal to P3 equal to the retention. Okay, compression aithe, if the applied load is compressive, it will be compression. So delta I. So is it clear, everyone? The free body diagrams, when you are drawing the free body diagram, it will come like that. Free body diagram nunchi manaki em ochindi? We will be getting individual forces, right? Delta I em ostundi manaki? Pi into Li by this Ai into E. Pi ante axial load in the ith segment. Delta I ante deformation in the ith segment. Li length of the ith segment. Ai cross section area of the ith segment, right? So total delta em ostundi? Delta of this CD plus BC plus this AB. Delta 1 plus this delta 2 plus this delta 3. Ante delta of this AB portion, delta of this BC portion, plus this delta of this CD portion. So what is that? P same kada? P same. So P1 L1 by this A1E plus P2 L2 by this A2E plus P3 L3 by this A3E. So P1, P2, P3 all are same. So you replace P1, P2, P3 with which one? P, like that, right? Like that we'll be having, right? Okay, that is what you are having. Load is applied only at one axial, one end. Then axial force in all segments will be same, right? Total deformation is which one? Sum of all the segments, right? Like that. Is this point clear, everyone? Stepped bars with axial load only at the one end. Is that clear, everyone? Andariki ardhamainda? Prismatic bar, stepped bar. Clear, everyone? Everyone is clear? Right. Now we'll go for stepped bars with intermediate force. Right now this is a cross section A2 we are having now. Yeah, here it is missing little bit. So this is the cross section of which one? This is second one, you can say, right? This is your second bar if you just observe A2. So that is your first bar with which one? This A1. Second bar with this A2 cross section, and third bar with this A3 cross section, and different lengths L1, L2 and this L3 we are having, right? Like that. Now tell me, if you are taking the free body diagrams A, B, C, D. Now always you come from which end? For drawing the free body diagram, always you come from which end? You tell me. Always you need to take from which end? Always you need to take from the external force applied side, right? External force akkada apply ayindi manaki CD మీద apply ayindi kada, akkadi nunchi enakki ellali. Free body diagrams if you draw. So what is the free body diagram for this one? Free body diagram if you draw, this is your CD portion. So for this is CD, what is there here? At D, load right side present is your P3, right? So kabatti member balancing kosam em undali? To balance the member, C దగ్గర left side em undali? P3 undali, right? At C also left side force P3 you'll be having, right? Now, so next, coming from C to B, C నుంచి Bకి వెళ్ళండి, ఏమొస్తుంది? C నుంచి Bకి వెళ్తే B point, right? So B point, and this is your which one? Sorry, this is your C point and this is your B point, right? At C, what is the external load applied? You tell me. P2 is the external load applied, na? P2 is the external load applied, right? P2 is the external load applied, right? So how can you get that? So, but left side ఏముంది మనకి? P3 ఉంది. కాబట్టి ఏం చేయాలి? దాన్ని ఎలిమినేట్ చేయాలి అంటే రైట్ సైడ్ P2 plus P3 if you apply, right? What it will become? Tell me. So C point దగ్గర right side P2 plus P3 is there, left side P3 is there. So what will be cancelled and what will be remaining? Tell me. At this is C point, for the above element CD element, left side P3 is there. So BC element, right side P2 plus P3 is there. So this is left side P3, right side P3 cancel అవుతాయి లేవా? Yes, left side P3, right side P3 cancels and we are left with P2, only the load applied, net load. So yes, we can consider like this na. So దీని మీద force ఏమొస్తుంది మనకి? Same P2 plus this P3. Is this clear everyone? The force on this BC? Everyone, force on this BC ఎలా వచ్చింది? అర్థమైందా అందరికి? Force on this BC, how we have got? Is it clear everyone? Someone respond. It is clear or not? Everyone tell me. It is clear or not? Hello. Now, coming to this AB member, right? Coming to this AB member. This is your A, this is your B. So at B, what is that net load we are having originally? The net load at B will be P1 on the right hand side, right? Net load at B will be P1 on the right hand side. So net force at B must be P1 on the right hand side, right? కాబట్టి మనకి ఏముంది ఇక్కడ యాక్చువల్గా BC పోర్షన్లో B దగ్గర ఏముంది? లెఫ్ట్ సైడ్ P2 plus P3. Suppose if you are applying that right side, that P2 plus this P3, they will be cancelled na. So at B, BC portion left side P2 plus P3, AB portion right side P2 plus P3, both will be cancelled. But what is the net value? P1 right side na. So here we'll add P1 right side. So what is that? P1 plus P2 plus P3. So left side also to balance the member AB. What is that left side force also? P1 plus this P2 plus this P3 we are having. Epudu? When all these are tension, right? When all these are tension, it will come like that. So what is the load in the segment? P1. Load in the segment 2, P1 plus P2. Load in the segment 3, P1 plus P2 plus P3. So all the loads, right? All the loads we'll consider, right? Take a section in the segment and consider all the loads on one side. So P1, P2, P3, axial loads in the tension only, right? Tension only, right? So tension positive, compression negative. A1, A2, A3, cross section areas. L1, L2, A3, lengths. So delta I, Pi, Li by this, Ai, E. Same. So delta 1 into P1 into first segment load is how much? P1 L1 by A1 E. Second segment load P1 plus P2 into L2 by this A2 E. Third segment load is how much? P1 plus P2 plus this P3 into L3 divided by this A3 into E, right? Is that clear everyone? How this equation came into picture? Is this clear all of you? How this equation comes into picture? Everyone? Is this clear? If it is clear, we'll just go for some other case. Is this clear all of you? Right? All are tensions only. But guarantee unda? All are tensions and guarantee unda? There may be some compressions also, right? There may be some compressions also, right? BC segment, right? You want me to explain the BC segment? Okay. When you are considering that BC segment, Mahendra, first CD, it is for CD segment, C point, what is that you are having? Left side P3 load is there, na? Okay, I'll explain here. What is that you are having? This for this is CD portion. For this is CD portion, right? For this is CD portion, right? What is there? CD portion ki emani cheppu? CD portion ki manaki ikkada right side P3 undi. So కాబట్టి ఇక్కడ లెఫ్ట్ సైడ్ ఏమొస్తుంది? మెంబర్ బ్యాలెన్సింగ్ కోసము P3 వస్తుంది. ఓకే, నెక్స్ట్ BC పోర్షన్ తీసుకున్నాం మనం, రైట్? వెన్ యూ ఆర్ టేకింగ్ దట్ BC పోర్షన్, So C point is present in BC portion as well as in this CD portion. So ఇక్కడ C దగ్గర నెట్ ఫోర్స్ ఏముంది, C పాయింట్ దగ్గర నెట్ ఫోర్స్ ఏముంది, P2 ఉంది కదా. C పాయింట్ దగ్గర నెట్ ఫోర్స్ P2 రైట్ సైడ్ ఉంది. సో మనకి ఇక్కడ నెట్ ఫోర్స్ రైట్ సైడ్ P2 కావాలి, రైట్. నెట్ ఫోర్స్ రైట్ సైడ్ P2 రావాలి. ఓకే. No, no, no. We don't take the fixed segment first. No, no, no. No, Shruti, we don't take the fixed segment first. Where the load is available, that we'll take, right? Where the load is available, that we'll take first, okay? Where the load is available, that we'll take first. So if you are taking that P3 segment, right, how can you get it? Tell me. Is it easy to get? No, no. It's not easy to get, right? In the previous one, you can take like that. In the previous one, load is same everywhere. But here, what happened at the middle portions also load is applied, na? You have to take from this load available only always, right? Exactly on this member, we know this load now. From P3 only we need to take. For finding that, what you need to do? See, Shruti, either you can take from fixed also. For taking from fixed, what we need to do? First, you need to find out the reactions. What is the reaction? P1 plus P2 plus P3 in the opposite direction. Na? So, you'll get that P1 plus P2 plus P3 in the opposite direction only. Na? So, for taking from the fixed end, you need to find out the reaction and you do. Both will be same. But instead of double calculation, I am saying that you go from this one. Okay? Is it clear? Yeah, Mahendra, coming to this. At C point, net load P2 right side is there. So, kabatti C దగ్గర ఏముండాలి? ఆల్రెడీ ఇక్కడ లెఫ్ట్ సైడ్ P3 ఉంది కాబట్టి మనం దాన్ని తీసేయాలి. We don't want P3. సో కాబట్టి రైట్ సైడ్ P3 అప్లై చేయాలి. సో లెఫ్ట్ సైడ్ P3, రైట్ సైడ్ P3 అప్లై చేసాం అనుకో ఏమవుతుంది? 0 అయిపోతుంది. బట్ మనకు 0 ఉందా C దగ్గర, రైట్ సైడ్ P2 ఉందా? రైట్ సైడ్ P2 is there, na? కాబట్టి ఏం చేయాలి? We need to apply this right side force only. P2 we need to add. So right side P2 plus P3, left side P3. What is the net value? P3 will cancel. Only that P2 right side we are left with. It is matching with this external force applied or not? Yes. Point is in equilibrium. So member BC equilibrium ఉండాలంటే ఏం చేయాలి? BC మీద రైట్ సైడ్ P2 plus P3 ఉంది. లెఫ్ట్ సైడ్ ఏముండాలి? P2 plus P3 ఉండాలి, రైట్. లెఫ్ట్ సైడ్ ఆల్సో P2 plus P3 ఉండాలి. That is how it will be balanced. Right, same for the AB member also. Is it clear, Mahendra, now? Is it clear, Mahendra, for BC portion? Is it clear now? Right. So coming to this, I will explain this. Mahendra, అర్థమైందా అంతా? Now, if you are taking this example, let us say there is no fixed support. Right. Okay. Okay. So actually this is segment. Let us take this as, okay, here numbering is given wrongly. This is a segment 3, na, right side. That is a segment 3. This is a segment 2. This is a segment 1. Yes, na? This is a segment 1. Okay. Right. That numbering is given ulta. Reverse it is typed. The typing mistake happened in that. Okay. Check it out. This is your P3, you take it. So this is your P3 plus this P2. This is your which one? This P1 plus P2 plus P3. Numbering koncham different ochindi. Check that numbering. Okay. That numbering is differently typed. Okay. Right. This is correct. Now, suppose if it is there here. This is first segment. This is a second segment. This is a third segment. Okay. So what are the lengths you are having? Tell me. These are the lengths. Na? What are the lengths? L1, L2 and this L3. Okay. L1, L2 and this L3 we are having, right? So now what we have applied? At this place that P4 is applied. Now at this place, right, what is it? Left side that P3 is applied. Okay. And at the junction, at this junction, right, what is it you can say? At this junction that P2 is applied. Right, P3, that is P2 is applied, and at this junction, right, what happened? That is where P3 is applied. Okay, at this junction, at what is there, P3 is applied, you can say. Okay, is it clear now? Is it clear? So sigma Fx equal to 0 means what is that condition? Tell me. Sum of the forces must be 0, na? Entire member must be in equilibrium or not? A, B, C, D, entire structure must be in equilibrium. So entire structure equilibrium lo undali ante condition enti? Entire structure equilibrium lo undali ante condition enti cheppandi? Left side forces, sum of the left side forces equal to sum of the right side forces. What are the left side forces? Tell me. So what are the left side forces? If you just observe, this is P1, you take it. Okay. P1, P2, P3, P4. Okay. What are the left side forces? P1 plus this P3 plus this P4. Okay. 1 second. Why it went suddenly? Right. P1 plus this P3 plus this. What happened here? Why it is changing? Okay. P4 equal to. Baba. What happened here? I don't understand. Some ghost came. It is equal to. What I did? It is equal to which one? I'll write below. That P1 plus this P3 plus this P4, right? P1 plus this P3 plus this P4 equal to, that is your P2, right? So P1, P3, P4 are left side, P2 is only right side, right? So this is how we are having. And that, what does it mean? What does it mean? P2 is very bigger value compared to all of them. Na? P2 is very big value compared to all of them or not? P2 is very big value compared to all of them. Okay. Now, so if you are considering the free body diagrams now one by one, tell me, we'll proceed from left to right or right to left. Which one you want? Tell me. We'll proceed from left to right or right to left. Which one you want? Tell me. Left to right eldama, right to left eldama. Left to right will go or right to left will go? Which one you want to tell me? We'll proceed in that manner only. Left to right or right to left? Which one you want? Everyone. Left to right you want or right to left you want? Tell me someone. Okay. Left to right? Okay, if you are taking that AB portion తీసుకున్నారనుకోండి ఏమవుతుంది? If you are taking that AB portion for this first segment, okay, left side ఏముంది మనకి? Load P1 ఉంది. So కాబట్టి to balance this member, left side in the entire member, left side P1 is there, right side also, right, what we should have? P2 should have. Okay, sorry, P1 only we should have. Left side P1 is there, right side also we should have which one? P1 only. That is what we are having. Now, next BC portion if you take, right? BC portion if you take, second one. This is your B, this is your C. Now, B daggara right side, right? At B, what is that we are having? Net force as P2 is there at B na? B daggara net force ఏముంది చెప్పండి? B దగ్గర నెట్ ఫోర్స్ వచ్చేసి P2 ఉంది, రైట్? B దగ్గర నెట్ ఫోర్స్ వచ్చేసి P2 ఉంది, అంతేనా? రైట్. P2 దట్టు రైట్ సైడ్ ఉంది కదా మనకి. P2 ఆన్ విచ్ సైడ్ ఇట్ ఈస్ దేర్? రైట్ సైడ్ ఇట్ ఈస్ దేర్ నా? రైట్ సైడ్ ఇట్ ఈస్ దేర్, రైట్? సో P2 రైట్ సైడ్ ఇట్ ఈస్ దేర్, రైట్? అండ్ హియర్ ఇక్కడ ఏమొస్తుంది మనకి? P2 రైట్ సైడ్ ఉండాలి మనకి, బట్ ఏముంది ఇక్కడ? రైట్ సైడ్ P1 ఉంది, రైట్ సైడ్ P1 ఉంది. సో కాబట్టి ఏంటి, మనం P2 రైట్ సైడ్ ఉండాలి కాబట్టి నెట్ ఫోర్స్ రైట్ సైడ్ పెట్టుకుందాము, దట్ P2. సపోజ్ if I'll take P2 minus this P1, right, what will happen? Tell me. P2 minus this P1, right, what will happen? Tell me. P2 minus this P1, right, what will happen? Tell me. ఈ రెండు ఫోర్సెస్ రైట్ సైడే కదా, సో నెట్ ఫోర్స్ ఎట్ దిస్ B ఎంత? నెట్ ఫోర్స్ ఎట్ దిస్ B ఏమవుతుంది చెప్పండి? ఇది రైట్ సైడ్ P1 ఉంది, సో రైట్ సైడ్ P1 ప్లస్ P1 ప్లస్ ఇది కూడా రైట్ సైడే ఉంది కాబట్టి ఏమొస్తుంది మనకి? P2 మైనస్ P1, P1 క్యాన్సిల్స్, రైట్? వాట్ వీఆర్ లెఫ్ట్ విత్ ప్లస్ P2, దట్ ఈస్ రైట్ సైడ్ ఓన్లీ, అంతేనా? ఇస్ ఇట్ క్లియర్? సో రైట్, సో క్యాన్సిల్, P1 క్యాన్సిల్ అయిపోతుంది కదా, ఎందుకు? minus P1 is there, plus P1 is there, both are right side. So P1 cancel, P2 net force we are left with. So it is giving the joint equilibrium or not? Joint equilibrium satisfied or not? Joint equilibrium satisfied కదా. సో మెంబర్ ఈక్విలిబ్రియం బీసీ మెంబర్ ఈక్విలిబ్రియం ఏంటి? రైట్ సైడ్ బి దగ్గర రైట్ సైడ్ P2 మైనస్ P1 ఉంటే సి దగ్గర ఏముండాలి? లెఫ్ట్ సైడ్ P2 మైనస్ P1 ఉండాలి. రైట్, లెఫ్ట్ సైడ్ P2 మైనస్ P1 ఉండాలి. ఈస్ దిస్ క్లియర్ నౌ ఎవ్రీవన్? ఈస్ దిస్ క్లియర్ ఎవ్రీవన్ నౌ దట్ ఫర్ దిస్ BC portion? Is this clear for this BC portion everyone? Clear all of you? Now we'll go for this CD portion. CD portion. So CD portion ki manamu we need not consider this, right? We can directly go from this left side, right? We can directly go from which one? This left side you can say, right? Sorry, we can directly go from this right side. Right side emundi force manaki? Right side em force undi? P4 kada. So simple ga left side also will consider this P4, right? Left side also will consider this P4. So ఇక్కడ నెట్ ఫోర్స్ ఎట్ దిస్ సి చేయండి, ఏమొస్తుంది? ఇది లెఫ్ట్ సైడ్. సో యూ టేక్ లెఫ్ట్ సైడ్ నెగటివ్, రైట్ సైడ్ పాజిటివ్, యూ టేక్ ఇట్, రైట్? ఏమొస్తుంది? మైనస్ ఆఫ్ దిస్. ఓకే, విల్ టేక్ లెఫ్ట్ సైడ్ పాజిటివ్, రైట్ సైడ్ నెగటివ్. సార్ ఇక్కడ P3 కన్సిడర్ చేయలేదు కదా. నెట్ ఫోర్స్ ఎట్ P ఏమొస్తుంది? నెట్ ఫోర్స్ ఎట్ సి ఏమొస్తుంది చెప్పండి ఒకసారి. వాట్ ఇస్ దట్ నెట్ ఫోర్స్ ఎట్ సి చెప్పండి. ఎనీవన్ టెల్ మీ వాట్ ఇస్ ద నెట్ ఫోర్స్ ఎట్ సి? సో లెఫ్ట్ సైడ్ ఇక్కడ P3 లెఫ్ట్ సైడ్ ఉంది కాబట్టి లెఫ్ట్ సైడ్ తీసుకుందాము. ఇదేంటి? P2 మైనస్ దిస్ P1 మైనస్ ఏంటది? P4. వాట్ ఇస్ దట్ వాల్యూ టెల్ మీ? వాట్ ఇస్ దట్ వాల్యూ టెల్ మీ? సో ఇక్కడ నుంచి మనం ఏం రాసుకోవచ్చు? P3 విల్ బి ఈక్వల్ టు ఈ P1 P4 నట్టు రాసామనుకో, P1 P4 నట్టు పంపించామనుకో, ఏమొస్తుంది మనకి? P2 మైనస్ P1 మైనస్ P4. అంటే P2 మైనస్ P1 మైనస్ P4 అంటే ఏమొస్తుంది మనకి? ఈజ్ ఇట్ నాట్ దట్ P3? ఈజ్ ఇట్ నాట్ దట్ P3? సో నెట్ ఫోర్స్ లెఫ్ట్ సైడ్ కదా. సో ఈజ్ ఇట్ నాట్ దట్ P3 మ్యాచింగ్ అట్ దిస్ లెఫ్ట్ సైడ్? సో P2 మైనస్ P1 లెఫ్ట్ సైడ్, P4 రైట్ సైడ్. సో P2 minus P1 minus P4, what is that net value? Left side P3 matching or not? Left side P3 matching. Is that clear now? So equilibrium condition is balanced or not? Equilibrium condition satisfying the? Equilibrium condition satisfying the? Yes, Swati, correct, right? Equilibrium condition satisfying the leda? Yes, equilibrium condition got satisfied, right? So now tell me what is the net deflection? Delta total ఏమొస్తుంది? Delta total ఏమొస్తుంది? Plus delta 1, right? Why plus delta 1? Because of this tension. ఇది P2 ఏంటి? సెకండ్ పోర్షన్ ఏంటి? కంప్రెషన్ కదా. సెకండ్ పోర్షన్ కంప్రెషన్ కాబట్టి మైనస్ డెల్టా 2, రైట్? వై మైనస్ ఇట్ ఈస్ కంప్రెషన్. థర్డ్ పోర్షన్ ఏంటి చెప్పండి? థర్డ్ పోర్షన్ ఏంటి చెప్పండి? థర్డ్ పోర్షన్ ఏంటి చెప్పండి? థర్డ్ పోర్షన్ ఈజ్ ఆల్సో కంప్రెషన్ కదా. థర్డ్ పోర్షన్ కూడా కంప్రెషన్ కాబట్టి మైనస్ డెల్టా 3, బికాస్ దిస్ ఈజ్ ఆల్సో కంప్రెషన్, రైట్? సో వాట్ ఈస్ దట్ వాల్యూ? Plus delta 1 is how much? Load on the first one is what? P1 PL, right? P1 L1 kada. Yeah, yes. So P1 L1 by this A1E. Next second enti? Load on this second portion is what? P2 minus this P1 kada. P2 minus this P1 into what is that? L2 divided by which one? This A2 E2. Next third portion, what is that? Minus delta 3. What is the force on this? P4 into L3 divided by this A3 E3. A3, okay? A3. Is that clear everyone? Is that clear everyone, all of you? Understood? Is that clear everyone? Understood all of you? Everyone it is clear or not? So equilibrium condition at joint, right? Equilibrium condition of the member, equilibrium condition of the entire structure we need to maintain, and we need to get like this, right? All these conditions are clear, all of you? Everyone? All these conditions are clear? Anyone having any doubt in this before we proceed to the next method? All these conditions are clear, all of you? Everyone it is clear? Right, okay, like that we'll do. Shall we take one example? Shall we take one example with the numerical? Right. If you just take it, చెప్పండి ఏమొస్తుంది here. సపోజ్ ఇలా ఉందనుకోండి, మనకి ఇక్కడ బాటమ్ ఫిక్స్డ్ సపోర్ట్ ఈస్ దేర్, రైట్? బాటమ్ ఫిక్స్డ్ సపోర్ట్ ఈస్ దేర్. దిస్ ఈజ్ ఏ, దిస్ ఈజ్ బి, దిస్ ఈజ్ సి ఈజ్ దేర్, రైట్? దట్ ఈజ్ ఏ, దిస్ ఈజ్ బి, దిస్ ఈజ్ సి, రైట్? సో ఏ దగ్గర ఏముంది మనకి? ఎట్ ఏ వీఆర్ హ్యావింగ్ ఏ డౌన్వర్డ్ ఫోర్స్ ఆఫ్ దిస్ 10 kilonewton. At B, what is it we are having? A downward force of which one? This is 25 kilonewton. Now tell me, AB మీద force ఏమొస్తుంది? What is the force on this AB member? Tell me everyone. What is the force on this AB member? దాని length cross section ఇచ్చేస్తే, if length and cross section are given, you can calculate the deformations. But tell me, what is the force on this AB? ఇక్కడ 10 ఉంది కాబట్టి 10 kilonewton compression ఆ tension ఆ? 10 kilonewton compression will come or 10 kilonewton tension will come? Tell me all of you. 10 kilonewton compression will come or 10 kilonewton tension will come? Which one will come, all of you? Based on this, tell me someone. Ten kilonewton compression? Yes. Why compression? Why compression? Because at A, it is a downward 10. So to balance this member equilibrium, upward 10 compression, right? This is your compressive in nature, right? Next, BC. If you are taking that BC portion, this is your BC. At B, what is that? Downward 25 kilonewton we want, but ikkada B దగ్గర ఏముంది? Upward 10 ఉంది. So how can you get a downward 25 then net value? If you are taking that downward 35, what will happen? Downward 35 minus upward 10. What it will become? Downward 25 will become, right? So like that. ఇది downward ఉంది కాబట్టి ఇక్కడ C దగ్గర ఏమొస్తుంది? Upward వస్తుంది 35. Is that clear now? Is that clear now? Why 35 comes? Why 35 comes? Is it clear? Because B దగ్గర నెట్ ఫోర్స్ ఏముంది? 25 డౌన్వర్డ్ ఉంది కాబట్టి ఇక్కడ 10 అప్వర్డ్ ఉంది కాబట్టి మనకి హయ్యర్ వాల్యూ B దగ్గర, ఇక్కడ BC పోర్షన్ లో హయ్యర్ వాల్యూ డౌన్వర్డ్ ఉండాలి. ఎంత ఉండాలి? ఇది 10 అప్వర్డ్ ని బ్యాలెన్స్ చేస్తూ టోటల్ వాల్యూ 25 రావాలి అంటే total value we should get 25, net value we should get 25 by balancing this 10 upward means, so downward 35, if you take, what it will become? Downward 35 minus upward 10, what it will become? Downward 25 at B, both together. So it is matching with the external load. Like that we need to take. Is that clear everyone? How to take that? Is that clear everyone? All of you, is that clear? Everyone, it is clear or not? How to take? So the load, right, what are completed? Axial deformation of a prismatic bar is completed. Stepped bars with the load acting only at the one end completed. Stepped bars with load acting at the intermediate locations also completed, right? Anyone having any doubt in this? Anyone having any doubt in this? Doubt unda evarikana ekkadana? Edaina doubt unte cheppandi, that we'll discuss before we proceed to the next items. Okay, right. Before we go to this, AW officers batch for APPSC and TGPSC start అయిపోయింది మనకి, రైట్? 20th July నుంచి కొత్త బ్యాచ్ స్టార్ట్ అవుతుంది. ఐ విల్ బి టేకింగ్ RCC. ఓకే, మండే నుంచి RCC స్టార్ట్ అవుతుంది. డోంట్ మిస్ దట్. AW తెలంగాణ అండ్ ఆంధ్రప్రదేశ్ ఆల్ ఎగ్జామినేషన్స్ కి యూజ్ అవుతుంది బ్యాచ్, ఓన్లీ టెక్నికల్ పార్ట్. ఓకే, పవర్ గ్రిడ్ బ్యాచ్ కూడా సేమ్ 20th July RCC తో స్టార్ట్ చేస్తున్నాను. It is only for Transco, Genco and Discoms AW. Okay, don't miss that. Right, APPSC, TGPSC, AW, Civil Engineering, Elite batch. Right, Elite batch means same previous batches only. Extra thing enti 1:1 mentorship వస్తుంది దీంట్లో, రైట్? ఛాంపియన్స్ బ్యాచ్ ఏంటి? టెక్నికల్ ప్లస్ జనరల్ స్టడీస్ కావాలనుకున్న వాళ్ళు ఛాంపియన్స్ బ్యాచ్ మీరు ఎన్రోల్ చేసుకోండి. ఓకేనా? రైట్, నౌ కమింగ్ టు దిస్ టాపర్డ్ బార్స్. Tapered bars with axial load. Okay, episode 3 ఇవాళ కరెక్టే పెట్టాను, elastic deformations and volumetric strain. Still we are in the elastic deformations only. Okay, so tapered bar with axial load అంటే దాంట్లో డిఫరెంట్ కండిషన్స్ ఉన్నాయి కదా. ఫస్ట్ టైప్ ఏంటి? ఫస్ట్ టైప్ ఏంటి మనకి? సర్క్యులర్ బార్ తీసుకున్నారనుకోండి. ఇఫ్ యు ఆర్ టేకింగ్ దట్ సర్క్యులర్ బార్, రైట్. సో ఇది పిపిటి చేయడానికి టైం అవ్వలేదు, అందుకే ఇంకా నేను చేయలేదన్నమాట డయాగ్రామ్స్ అవన్నీ. సో దట్స్ వీఆర్ డూయింగ్ మాన్యువల్లీ, రైట్. ఏమవుతుంది మనకి హియర్? వాట్ విల్ కన్సిడర్? సర్క్యులర్ బార్ కి ఒక సైడ్ డయామీటర్ ఏంటి? వన్ సైడ్ డయామీటర్ ఈజ్ విచ్ వన్? దిస్ క్యాపిటల్ డి. క్యాపిటల్ డి ఈజ్ ద వన్ సైడ్ డయామీటర్. లేదు D1 అని పెట్టుకోండి, రైట్. D1 యూ కీప్ ఇట్. అదర్ సైడ్ డయామీటర్, ఇట్ ఈస్ tapered like that. To which diameter you can say? It is tapered to which diameter? That is your D2 diameter. Okay, D2 diameter. Now what is the length of this? This is the length. And what is the axis? Center will be here only, no? This is the axis. సో యాక్సిస్ దగ్గర అప్లై చేసే లోడ్ ఏంటి? యాక్సియల్ లోడ్, రైట్. ఇలా టెన్షన్ లేదా కంప్రెషన్ అప్లై చేస్తాం. ఓకే, either will apply tension or will apply compression, right? Now tell me, what is that deflection and net deformation? Anyone having idea? Tell me. Always we need to neglect which one? Self weight. Self weight is neglected. So what is the deformation? Anyone having idea? Right? What is the deformation? Anyone having idea? What is the deformation here comes to be? సో ఇది ఎలా వస్తుందంటే 4PL డివైడెడ్ బై దిస్ పై ఈ D1 D2. ఓకే, 4PL బై దిస్ పై ఈ D1 D2. సార్ ఎలా వచ్చింది సార్ ఇది? సపోజ్ ఇఫ్ యు ఆర్ టేకింగ్ ద సర్క్యులర్ ప్రిజ్మాటిక్ బార్ ఆఫ్ డయామీటర్ D, సర్క్యులర్ ప్రిజ్మాటిక్ బార్ ఆఫ్ డయామీటర్ D విత్ దిస్ లోడ్ తీసుకున్నాం అనుకోండి, ఏమొస్తుంది మనకి? డూ యూ రిమెంబర్ దట్? డెల్టా ఈక్వల్ టు వాట్ ఈస్ దట్? PL బై దిస్ AE కదా, PL బై దిస్ EA కదా. ఏ అంటే ఏంటి? PL డివైడ్ బై దిస్ E ఇంటూ పై బై 4D². పై ఇక్కడ రాస్తాము, 4 పైన రాస్తాము, D² ఇక్కడ రాస్తాము. సో ఇక్కడ whenever you are having the same diameter throughout, it will be D². So if you are having different diameter, D1 into D2, ante teda. Is it easy to remember? Is it easy to get or difficult to get? Tell me. Prismatic bar formula nunchi easy ga తీసుకురావచ్చా? By observing the prismatic bar formula, we can get this easily or not? By observing from the prismatic bar formula, we can get this easily or not? Yes, we can get that easily. Is it clear everyone? Circular bar, how to remember the formula? Is it clear everyone? All of you? Clear or not? Yes or no? సో ఇక్కడ సేమ్ డయామీటర్ DD ఉంటే D ఇంటూ D వస్తుంది. ఇక్కడ D² ఎలా రాస్తాం మనము? 4PL బై దిస్ E లేదంటే పై ఈ D ఇంటూ దర్ D, రైట్. D ఇంటూ దర్ D. ఓకే, సో ఇక్కడ డిఫరెంట్ డయామీటర్స్ ఉన్నాయి కాబట్టి D1 ఇంటూ D2 వస్తుంది, అంతే తేడా. ఓకే, ఇస్ అ క్లియర్? రైట్. షల్ మూవ్ టు ద సెకండ్ టైప్. సెకండ్ టైప్కి వెళ్ళామనుకోండి, సెకండ్ టైప్ ఏంటది? బార్ ఆఫ్ యూనిఫామ్ థిక్నెస్, టాపర్డ్ బారే. ఇది కూడా టాపర్డ్, 3 రకాల టాపర్డ్ బార్స్ ఉన్నాయి. బార్ ఆఫ్ యూనిఫామ్ థిక్నెస్ విత్ వేరియింగ్ విడ్త్. ఏం కండిషన్ అది? బార్ ఆఫ్ యూనిఫామ్ థిక్నెస్ బట్ వేరియింగ్ విడ్త్. సో వాట్ విల్ హ్యాపెన్? టెల్ మీ, ఎలా వస్తుంది ఇది? హౌ యూ విల్ బి గెటింగ్ దిస్? టెల్ మీ ఎనీవన్. సో బార్ ఆఫ్ థిక్నెస్ యూనిఫామ్ గా ఉంటుంది, బట్ ఏం వేరీ అవుతుంది? విడ్త్ వేరీ అవుతుంది, రైట్. విడ్త్ వేరీ అవుతుంది, రైట్. ఎలా వస్తుంది మనకి? హౌ యూ విల్ బి గెటింగ్ దట్? సో హియర్ దిస్ ఈజ్ లైక్ దిస్. సో దిస్ ఈజ్ యువర్ విచ్ వన్? దిస్, రైట్. ఇలా వస్తుంది మనకి. సో థిక్నెస్ సేమ్ ఉంటుంది, బట్ విడ్త్ ఏమవుతుంది, మారిపోతుంది, రైట్. థిక్నెస్ విల్ బి సేమ్ బట్ విడ్త్ విల్ బి డిక్రీజ్, రైట్. విడ్త్ విల్ బి డిక్రీజ్డ్, యూ కెన్ సే, రైట్. సో హౌ ఇట్ విల్ బి నౌ, ఇట్ విల్ బి లైక్ దిస్ నా. Compared to the left width, this right width will be lesser na. So ఇది దీనికి జాయిన్ అవుతుంది, this will be joining this one. Okay, so this is the length of this tapered bar. So now what is that uniform thickness here, this is t, this is t, right. Thickness will be uniform here everywhere, but width ఏం వస్తుంది, ఇక్కడ వచ్చేసి b1, right. Here what is that you are having, here what is that you are having, tell me. Capital B రాద్దామా, b1 b2 రాద్దామా, which one you will write, tell me. We'll write a capital B or b1 b2, which one you are comfortable with. Capital B తోట b1 b2 రాద్దామా, tell me someone. Mister, b1 b2 will use or capital B small b will use, someone tell me, I'll go according to that only. So what is the delta change in the length will be, PL by this E into the T into, so higher B minus this lesser B into that log to the base A higher B by this lesser B. Okay, చెప్పండి ఏం రాద్దాము, what shall we write. Capital B small b will write or b1 b2 will write, tell me ఏం రాద్దాం, which one you wanted, which one you are familiar with. Capital B small b or no one is responding. Capital B small b na b1 b2 na, ఏది కావాలి మీకు, what you want. అరే ఎవరు రెస్పాండ్ అవ్వట్లేదు, why. Varying width అది, varying width, that is not varying width, varying width. Okay, shall we use b1 b2 or we'll use that capital B small b, tell me someone. b1 b2, b1 b2, not b1 b2, width. Okay, so okay, let us take it as this b1, let us take it, let us take this width as which one, this b2, right. Let us take this width as this b2, right. So ఇక్కడ ఏంటి, b1 is greater than this b2 కదా, b1 greater than b2 అయినప్పుడు ఏం చేయాలి అంటే, ఇక్కడ మనకి ఏమొస్తుంది, ఇక్కడ b1 మైనస్ దిస్ b2 రాయాలి, ఇక్కడ b1 బై దిస్ b2, సింపుల్ గా హయ్యర్ విడ్త్ మైనస్ లోవర్ విడ్త్, ఇక్కడ వచ్చేసి హయ్యర్ విడ్త్ బై దిస్ లోవర్ విడ్త్, రైట్. హయ్యర్ విడ్త్ బై దిస్ లోవర్ విడ్త్, we need to write. This is how we'll be getting the deflection. Is that clear? Is this clear now? Is this clear now? Bar of this uniform thickness but with varying width, right. Width is varying but the thickness will be same everywhere, right. Width is varying but the thickness will be same everywhere, right. Is that clear all of you? Is this clear everyone? Clear all of you? Right. Okay, now we'll go to the last case of this tapered bars, third case, right. What is it, you can say tapered square bar. Tapered square bar. So what is the meaning of this tapered square bar, tell me. Tapered square bar meaning enti, so tapered square bar means square cross section, so but with change in the dimension, right. With change in the dimension, right. Suppose if you are considering this here, let us say, for this also which one will use, b1 b2 will use or ab will use, tell me. It will be like this and it will be having the increasing the width na, increasing the width will be having, right. This width will be increased, right. So compared to this right side width, this left side width is increased na, so same dimensions are there, right. Here this side also this is higher, compared to this right side this is higher. Okay, it will be like this. Okay, this is P, this is P load applied. So tell me which dimensions we'll use, AB will use or we'll use which one, that is your delta will be equal to, right, delta will be equal to that PL divided by this, right. What is it, tell me, what is that PL divided by how much, What it will come, tell me? Generally, suppose manaki square bar undanukondi, whenever you are having a square bar, dantloంచే తీసుకురావాలన్నమాట. Whenever you are having a square prismatic bar, let us say like this. స్క్వేర్ ప్రిజ్మాటిక్ బార్కి ఏంటి ఏ అని తీసుకుంటాం ఇక్కడ అన్ని సైడ్స్. ఏమొస్తుంది డెల్టా ఇక్కడ ఏమొస్తుంది మనకి పిఎల్ బై దిస్ ఏరియా ఏమొస్తుంది ఏ ఇంటూ దట్ ఏ కదా, ఏ ఇంటూ దట్ ఈ కదా. సో బట్ ఇక్కడ ఏముంది అంటే మనకి ఒక సైడ్ ఏ ఉంది, వన్ సైడ్ ద స్క్వేర్ సైజ్ ఈజ్ ఏ, అదర్ సైడ్ లెట్ us say ద స్క్వేర్ సైడ్ ఈజ్ బి. ఇప్పుడు ఏమొస్తుంది సేమ్ ఉన్నప్పుడు ఏ ఇంటూ ఏ వచ్చింది, డిఫరెంట్ ఉన్నప్పుడు ఏమొస్తుంది మనకి డిఫరెంట్ ఉన్నప్పుడు ఏమొస్తుంది ఏ ఇంటూ బి వస్తుంది, రైట్? సేమ్ యాజ్ దట్ ఆఫ్ యువర్ సర్క్యులర్ వన్ ఓన్లీ యువర్ హ్యావింగ్. సర్క్యులర్కి చేసాం కదా, టాపర్డ్ సర్క్యులర్కి ఎలాగనో కాన్సెప్ట్, దీని కూడా అలానేనా? వీ కెన్ రిమెంబర్ లైక్ దిస్ ఆర్ నాట్? ఎస్, వీ కెన్ రిమెంబర్ లైక్ దిస్. ఇస్ అ క్లియర్ ఎవ్రీ వన్? ఇస్ అ క్లియర్ ఆల్ ఆఫ్ యూ? ఇస్ దిస్ క్లియర్ ఎవ్రీ వన్? Everyone, it is clear or not? Someone tell me. Anyone having any doubt in this? Someone respond. So when square prismatic is there, a into a, area is what? A into a for square. But ikkada one side a, one side b undi kabatti a into b vastundi, right? Similar to this one only, no? Similar to this one only, no? D into d. Instead of this d into d, we are having d1 into d2 because of different diameters. Same here also, no? Instead of a into b we are having. Instead of a into a, we are having a into b, like that. Is it clear? So axial deformations of this tapered bars. Everyone, it is clear? Axial deformation of this tapered bars is the clear, everyone? Clear all of you? Everyone clear? Right. Next we'll go for this last topic under this. What is it? Volumetric strain. Okay, what is it you can say? Volumetric strain. So next class, Monday or Tuesday I'll take. In that deformation due to self-weight bar of uniform strength composite bars, those deformations I'll take. One more class I'll take, which one? This temperature stresses. With that, this will be over. Okay. Volumetric strains. Okay, elastic deformations and volumetric strains we'll see. So here there are different types we are having. Elastic deformation of which one? This is standard bodies we'll see, right? So what is that? Yeah, change in the pressure by this no, volumetric strain means change in the volume by this original volume only. Change in the volume by this original volume only. Suppose rectangular bar is there. Okay, whenever it is a rectangular prismatic bar is there. What is that rectangular prismatic bar if you just consider? So rectangular prismatic bar means that we are having different dimensions, na? ఏమేమి ఉంటాయి dimensions rectangular prismatic bar కి మనకి? Rectangular prismatic bar, right? What is that you are having? This is your length L is there. So this is your which one? This width B is there. This is your which one? This depth D is there, right? So now tell me, right, what is that volume? Tell me if you just observe. What is that volume? Volume is nothing but your LBD kada. What is that volume? Volume is nothing but your which one? This volume is nothing but your LBD. Okay? Volume is nothing but your LBD. So volumetric strain ante enti manaki? Volumetric strain is nothing but change in the volume by this original volume, right? Volumetric strain is what? Change in the volume by this original volume, you can say. Now if you are applying that differentiation to this, right, partial deformation, at what it will become? First you keep which one? Differentiation in the length, right? So dl. Okay, dl instead of dl we'll write delta endukante dt confusion avutam kabatti. First partial differentiation if you apply, right? What is that partial differentiation? Delta L. So differentiation of partial differentiation of this L, BD will keep as it is, plus second one L and D will keep it as it is, and partial differentiation of em vastundi B vastundi. plus what is that, LB will keep it as it is, and partial differentiation of ఏమొస్తుంది, depth వస్తుంది, right? This is how we'll be getting. Okay, so this is how we'll be getting it. Now tell me, what is that a volumetric strain we'll be getting? That is your delta V by this V only, no? What is the delta V by this V? Tell me. Delta L into that BD plus this L into that delta B D divided by this total. Okay, plus what is that, LB into that delta D divided by which one, this LBD. So what it comes to be finally, so delta BD cancels, right? We are left with which one, this delta L by this L, plus second one LD will cancel, we are left with which one, delta B by this B, plus what is that, LB cancelled, and we are left with which one, this delta D by this D. So what it comes to be finally, that is nothing but your epsilon L. Delta L by this L is nothing but which one, change in the length by this original length is nothing but strain in the length. Delta B by B is what, change in the width by this original width is nothing but strain in the width. Change in the depth by this original depth is nothing but your which one, this strain in the depth. So therefore, what is that epsilon V for this, tell me? Epsilon L plus this epsilon B plus this epsilon D, like that. Is it clear how we have got? Is it clear how we have got this, everyone? Is it clear, everyone, how we have got this? All of you. Clear or not? For a cube. For a cube, ఏమవుతుంది మనకి, L equal to that, B equal to that, D will be equal to, let us say, A we are having, right? Clear, everyone, all of you? Right? So when you are having it like this, a cube, what it comes to be, this is A, this is A, and this is also A, no? All sides are A only, no? Tell me, what is the volume of this cube? Tell me. A cube is the volume, and tell me, what is that delta V? Tell me. Differentiation if you are doing for this A cube. Differentiation if you are doing for this A cube, right? What is that you will get? Tell me. 3 times that A square into, right, what is that you can say? That is your delta A. Na? Now tell me, volumetric strain, how can you get that? Change in the volume by this original volume. What is the change in the volume? 3 times this A square into the delta A divided by which one, this A cube, right? We are left with which one, tell me? 3 times delta A by this A. So what is the delta A by this A? 3 times strain in that side A. So this means what is that? Volumetric strain will be equal to 3 times that strain in that one side. 3 times strain in that one side. Is that clear, everyone? For cube, how we are getting? For cube, how we are getting? Is that clear? Is this clear, everyone? For cube, how we are getting? So ఇక్కడ A cube ఉంది కాబట్టి వాల్యూమ్ ఈక్వల్ టు A cube కాబట్టి 3 టైమ్స్ వస్తుంది. పవర్ 3 ఉంటే 3 టైమ్స్ వస్తుంది. ఇక్కడ L పవర్ 1 ఉంది కాబట్టి 1 టైమ్ ఎప్సిలాన్ L, B పవర్ 1 ఉంది కాబట్టి 1 టైమ్ ఎప్సిలాన్ B, D పవర్ 1 ఉంది కాబట్టి 1 టైమ్ ఎప్సిలాన్ D, right? Like that you'll be getting. Is that clear, everyone? Shall we go to the other two cases? Clear, everyone? Right. Third one, right? What is your third one? Tell me. Cylinder. So whenever it is a cylinder, right, what is it you can say? This is your cylinder, na? This is your cylinder or not, right? That is your cylinder, right? So what is the volume for this? Tell me. What is the volume for this? Tell me. What is the volume? Area, cross-section area is what? Pi d square by this 4 into L, right? So ఇది వచ్చేసి ఏంటి మనకి L, ఇది వచ్చేసి ఏంటి మనకి diameter D. So direct గా ఎలా రాయొచ్చు మనము? How can you write that epsilon V? Epsilon V we can write it as pi by 4 constant eliminate చేస్తాము. D square is there. So 2 times this strain in the diameter plus strain in the length. Okay. Directly can we write D square is there. So D power 2 is there means that 2 will come as a multiplication. ఇక్కడ 3 ఉంటే ఏమవుతుంది? A cube is there. That 3 will, that power 3 will come as a multiplication. ఇక్కడ D square, D power 2 is there. That 2 will come as a multiplication. Plus L is also there, no? L ఉంది కాబట్టి ఏమొస్తుంది మనకి ఎప్సిలాన్ L వస్తుంది. Is it correct? Is it correct? So directly we can write like that. Directly we can write like that. So shall I prove how it came or no need? Tell me all of you. Shall I prove this or no need? Shall I prove this or no need? All of you. Okay. Volume ఇది. మనం ఇప్పుడు డెల్టా V తీసుకున్నాం అనుకోండి. If you are taking that delta V, right, what happens? Tell me. Pi by 4 we will be keeping it as it is. D square differentiation what will do? 2 times that D into that delta D into L as it is. Plus what is that? D square will keep it as it is and delta L we are having. Okay. And what is that volumetric strain now? Tell me. Delta V by this V kada. So delta V anta? Pi by 4 into pi by 4 into ikkada D okati pi by 4 into, right, what is that we can take common? Only D we can take common na. Pi by 4 into that D we can take common. So what you are left with? 2 times this delta D into that L plus oka D బయటకు వచ్చేసింది కదా, D into that delta L divided by, right, what is that you are having? That is your pi by 4 into that D square L. This pi by 4 will cancel, 1 D cancels. What is that you are left with? Tell me now. 2 times delta, this LL cancelled. What is that you are left with? 2 times this delta D by this D kada. Plus this one, right, what will happen? Tell me. DD cancels, right, delta L by this L. So what is that? 2 times delta D by this D is nothing but strain in the diameter plus delta L by L is nothing but your strain in the length. Are we getting the same thing or not? Are we getting the strain? Are we getting the same thing? Yeah, Bhaskar. Yes, I have proved. Are we getting the same thing or different thing? Tell me. Are we getting the same or different? Yes, we are getting the same, right? Yes, we are getting the same, absolutely, right? Is it clear, all of you? Understood, everyone? అంటే మనం పవర్ ఉన్నప్పుడు, రైట్, పవర్ ఉన్నప్పుడు డైరెక్ట్గా రాయొచ్చు మనము, రైట్? ఎస్నా? ఇంకా ఏముంది? ఇంకా వాట్ ఈస్ అనదర్ వన్ యూ కెన్ సే? అనదర్ వన్ ఈజ్ వాట్? Sphere. So sphere, what is the volume of this sphere? Tell me. What is the volume of this sphere, everyone? What is the volume of this sphere? Someone tell me. Anyone tell me, right, what is the volume of this sphere if you remember? That is your pi d cube by this 6 kada. Pi d cube by this 6. So this is the diameter of this sphere, right? Pi d cube by this 6, right? So directly how can you write that? Epsilon V will be equal to, so pi by 6 constant, so no variation, we don't consider. D cube is there, power 3 will come as a multiplication and strain in the diameter, 3 times strain in the diameter. Is it clear, everyone? Is it clear, everyone? Shall I prove this or no need for this sphere? Shall I prove this for sphere or no need? We can get in the similar manner. For sphere we can get it in the similar manner, na? Yes or no? For sphere we can get it in the similar manner if you just observe, right? No need to prove. Shall I? Shall I prove or no need, all of you? Cheppandi. Prove cheyala avasar leda? Do I need to prove it or no need? No need, huh? Okay then. So next, what is another one you are having? Cone. What is their cone? Tell me. What is their cone? Whenever you are having a cone like this. So tell me, what is the volume of this cone if you just observe in terms of this diameter? This is your diameter D and this is your which one? This height H, right? Height H, right? Tell me, what is the volume of this cone if you just observe? Tell me, everyone, right, what is the volume of this cone, all of you? What is the volume of this cone? Anyone tell me the volume of cone? Someone? In diameter, in terms of diameter, if you just observe, right, what is that? Okay, if you are going with the radius, 1/3 of pi r square h na, or we can use it as d by 2. So d square by this 4 into 3, 12 it will become, right? What is that? V 1 by 12 pi d square h, right? 1 by 12 pi d square h we are having, right? 1 by 12 pi d square h, right? In terms of this diameter, right? Now tell me, what is the epsilon v for this? Tell me, what is the epsilon v? I will not write. You just tell me, everyone. All of you, based on the discussion till now, you tell me, everyone, what is it? What is the volumetric strain we'll get here? What is the volumetric strain we'll get here? Tell me. Tell me what is it, everyone. సో టుమారో ఎట్ 5 PM, రైట్? రేపు 5 PMకి మనం ఏం డిస్కస్ చేస్తున్నాము? జనరల్ గ్రూప్ డిస్కషన్ బై స్టూడెంట్స్ అండ్ మీ విల్ బి దేర్, రైట్? ఒక 5 స్టూడెంట్స్ లైవ్లో ఉంటారు. ఒక టాపిక్ ఏంటది? హిస్టారికల్ బ్యాక్గ్రౌండ్, రైట్? కంపెనీ రూల్, ఈస్ట్ ఇండియా కంపెనీ రూల్ మీద డిస్కషన్ జరుగుతుంది. డోంట్ మిస్ దట్. Sushmita said 2 times, right? Pi d square is there, na? So what it will become? 2 times this epsilon d plus h power 1 is only there, na? So kabatti emoutundi, h power 1 is only there means epsilon h. Yes, absolutely correct, right? This is how we'll be getting which one? This is how we'll be getting this volumetric strain, right? Is it clear, all of you, the volumetric strains? Is it clear, everyone, the volumetric strains, all of you? The volumetric strains are clear, all of you? Anyone having any doubt? Are these volumetric strains clear, everyone? Right? So we'll, if everything is clear, right, we'll close here. So next, when we'll take next class on which one? This Monday we'll take mostly. Next class on this Monday at this 7 PM we'll take, right? Sunday we don't have class. Sunday we'll be having 5 PM another class, right? Okay, 7 PM on which one? Self weight deformation. Okay, deformation due to self weight we'll take, right? Deformation due to that self weight we'll consider, and plus which one? Composite bars also, right? Composite members we'll take, and also we'll take which one? This bar of uniform strength, right? Composite దగ్గర మనకు టైం అంతా పోతుంది. Okay, composite only will take a lot of time. Bar of uniform strength, right? These 3 topics we'll discuss on Monday. Okay, SOM. Okay, episode 4, that is episode 4 we are having. Now tomorrow what will be having? రేపు ఏముంటుంది? టుమారో ఏంటది? 19th కదా? 19/7/26, రైట్? మండే అంటే ఏంటి? 27/26. And okay, tomorrow, right, what we will be having, right? At 5 PM we'll be having which one? Tell me. 5 PM కి ఏముంటుంది మనకి? Polity group discussion, right? Polity live group discussion ఉంటుంది. Okay, don't miss that. Yeah, tomorrow this is a class. So who will be there? RP sir will be there, plus 5 students will be there. This is the live discussion will happen, right? Some 4 or 5 students will be there, right? And on 20th 7/26, right, what is that? New batch will be starting, right? New batch. Those who are willing to go for this APPSC, TGPSC, AP Transco, Genco, new batch will be starting with which one? This RCC subject. RCC subject at which one? 6 AM. Okay, please do subscribe for this, right? Don't miss that. And Rankers Pro is launching GATE courses also. Environmental Engineering by KP sir. 16th July it was started already. My subjects also will start. Don't miss that, right? So KP sir full course Environmental Engineering. 2028 GATE and ESC batches will be having. And these are the list of batches. So on 16th July, environmental engineering. 6th August, BMK sir will start mathematics. 20th August, I will be starting transportation. 20th August, again CPM part will be started by KP sir. Geotechnical by KP sir on 3rd September. 17th September, aptitude. And 1st October, irrigation. 15th October, fluid mechanics. 5th November, open channel flow. These are the subjects for 2027 will be started. Okay. 2028, I will be starting all my structural subjects and surveying also. 2027 we'll try to include surveying once this transportation over. Okay na? October mostly. So one batch for all examination, achievers batch. You subscribe for this batch and you crack any examination in India. Okay. Thank you guys. Download the Rankers Prep. Subscribe to this YouTube channel. Share the link of this YouTube channel with all your friends. Share the link of this app with all your friends. Join the Telegram channel. Any doubts are there? Anyone wanted to take the subscription? Will be you just contact.